Hello team, this challenge is Unorder of Operations, where we're given an array of numbers and an array of operators, which can include all these standard ones, and we need to iterate over them and alternate between all of our operators. So if we had two or three or even one, I guess, right? We need to do that math. So it would be 5 plus 6 minus 7 plus 8 minus 9. And if you did that, you would get 3. And so on down the line, just like this. The hardest part about this challenge is the operators, because the operators cannot be coerced into their JavaScript equivalents, right? So because these are strings, we can't just go index 0, index 0, index 1, and have it somehow just magically work, right? In theory, maybe we could use something like eval. We are not going to do that today because eval is dangerous, right? And you need to be a lot more knowledgeable about that if you're going to use it. Otherwise, it's a security risk. It's a huge security risk. So no eval today. We're going to have to figure out how to cover off these operators, okay? That looks like this. So we go over here and we start out with a function that I'm going to call do maths. Okay, do maths takes number 1 and number 2 and the operator. Okay, and then from there we do a switch statement. So switch, just like this, on the operator, doing some stuff. What are we doing? It's going to be case plus, right? That's the first operator. You could start anywhere. It doesn't matter. But and I'm going to keep that same sort of level. So right here we have that, which means that we return n1 plus n2. Okay. And then we bring that down and we change this to a minus, just like this, and bring it down. Oh, it's jumping around because I had multiple cursors. Bring it down, bring it down, bring it down, right? This one is going to be the multiplied, so that's going to be the asterisk. This is divide, so we can do that with the slash. And this one is the modulo, which is the percent sign, right? Percent sign. Right here, we should always return something, right? If they pass in an operator that we have not accounted for, what are we returning? What message are we returning for that? Okay, if they pass in, say, the double asterisk, which would be the power of, raising something to the power of, right? We don't have a case for that. So what we should do is, for default, we should not return a string. We should throw new error. And that error can be operator not found, right? Something useful. Operator not recognized, operator not found. Something that helps us figure out why our math is failing, okay? With that, we go down here and we do the work. So right here, we're going to reduce. And what are we reducing on? Well, we need the accumulator and the current and the index, okay? The index is how we reach into operators. So that's where that comes in. But right here, we do it. Now, normally we would put in some sort of a thing to start us off here, right? Maybe it would be 0 or maybe it would be numbers 1, right? Or numbers 0, sorry. If we leave this empty, it's actually going to take that first value, which is very handy. That's what we want. We want that first value to be the accumulator. And then we start the process going, okay? But with that, we also need to figure out what our operator is. So let's do that. That's going to be op. It's going to be equal to operators. I almost shortened that because I really, really want to. And we're going to reach in and get a number, okay? Normally you would do something like index modulo operators dot length, okay, which I just realized is being calculated every single time, right? Like that's kind of silly. Let's take that out for a second and make its own thing. Const ops length like this. And that way it's only calculated once. It's a bit of a performance boost, okay? But the problem here is that our index is off, right? Our index is absolutely off. So if we go and we bring that in, we return do maths, right? Do maths for what? Well, it's going to be the accumulator and the current and the operator, right? And and it throws an error. And it should, because our index is off. We automatically slotted numbers 0 as our first value, but our index is now representing something that is not right. So when we reach in to get the operator, we're off by 1. Okay. The secret to that is to wrap this up, to go -1 so that we back it up by 1 to get to the right start for numbers, at which point now it works. Okay. And it works quite well, right? We don't have to do any sort of magic. If that's a little bit confusing to you, okay, or you want to write it a different way, right? That is definitely possible. So something that we could do really fast, just to show you what that would look like, is right here. We could go not like that, dot slice, right? And we slice from 1 to the end. Okay, great. And then down here, we set our initial value to numbers of 0, right? And then now we can replace this with index, and it still works. So the off by 1 is definitely how it's loading in that number 0 in this code up here. Okay. I still like this, and I would probably stay with that, but it might need a comment, right? Or somebody might go, what is going on? Why is there no initial value? Maybe they try to add 0 and now it's broken again, right? So if you're not comfortable with reduce, this might be the wrong way, but it does get it done today. So with that, we created a function to coerce our string operators into the operators themselves. So we did all that. We also added a helpful message in case they pass in an operator that we don't have access to, right? Making sure that still works. And then down here, we did exactly that. We looped over our numbers and went back and forth on the operator, always returning whatever that result was, right? This is just an accumulator, so we didn't need to have an accumulator plus something. We just need to do the extra work, okay? And that's it. Again, if this one makes more sense, I actually started with this one, and then I realized that I could cut the slice away. So power to you, right? Let me know which one you like, which one you hate. If you went a different way, for sorting out these operators, let me know all that stuff in the comments. Otherwise, for today, this has been Unorder of Operations, and I will see you in the next one.